Kelsey and Amy, thank you for that question. Let's look at what we got here. So the first part you have just drawn the vertical and horizontal component, and you verified your velocity. So that's your x component and that's y component. That looks great so far. Okay. This is what you use to find out your distance, which is fair. So good. This is the correct way to find out what time did it take. You could have also used v is equal to u plus at, and that's what you have used, and you could have used yeah. So pretty much that's perfect. The only issue is right here. So this is something that I have not introduced in the class. This is something that we did not discuss about, and that's great that you used it and you dig into it. It was in the textbook. The only thing funny is it is range of the projectile. Now, if this is how your projectile was launched from this point, and it fell all the way up in the height to reach its maximum height, and over here it kind of exploded. So what is the range going to be? It's going to be up till here, right? But the formula that you have used will give you range of a projectile all the way back until this point, which you do not want. You want your range up till this point. So the best and easiest way to do it is using the same equation that we always use. So now you have time, now you have initial velocity on the x, so you will say x, which is range, is equal to v initial, I give my handwriting, on x times t, which is equal to 10 times 1.77, and whatever your answer is, that's going to be your solution. So that was one part which was not correct. So great that you used it. Now you know how to use it for the questions, but in this context it's not going to be this. It is going to be, I think, 17.7. So it's going to be exactly half of what you got. Thumbs up.